Today we're building a fully functional HTTP web server from scratch in a single Java class. This isn't a toy, it serves static files, generates directory listings, handles GET and POST requests, provides a REST API, and logs every request with color-coded output. We'll use Java's networking, file I/O, concurrency, and date/time APIs. By the end, you'll have a server you can actually use to host a website or test your front-end code. We begin by importing everything we need: java.io, java.net, java.neo.file, java.time, java.util, java.util.concurrent, and java.util.regex. The class TinyWebServer is declared with several configuration fields: the port number, a path for the document root, a cached thread pool executor, a volatile boolean for the running state, a server socket, and atomic counters for request and error counts. We also define ANSI color constants for console logging and a map of MIME types. The constructor takes a port and a document root path. It initializes the thread pool and creates the document root directory if it doesn't exist, printing its absolute path. This ensures the server has somewhere to serve files from immediately upon startup. The start method creates a server socket on the specified port, sets the running flag, and submits a task to the thread pool. That task runs an accept loop. It blocks on server socket.accept, and, for each incoming connection, submits another task that calls handle client. The stop method sets the running flag to false, closes the server socket, shuts down the thread pool, and waits up to 5 seconds for active tasks to finish. This clean shutdown prevents resource leaks. Handle client is the heart of request processing. It uses try-with resources to manage the socket, a buffered reader for input, and an output stream for output. It reads the request line, e.g., get/index.html http/1.1, and splits it into method, path, and version. Then it reads headers line by line until an empty line, storing them in a map. For post requests, it checks the content length header and reads the exact number of body characters. This manual HTTP parsing is what every web framework does internally. After parsing, the server checks if the path starts with API. If so, it routes to the API handler. Otherwise, it calls serve static. That method performs security checks, it removes and double slashes to prevent directory traversal, appends index.html for directory paths, and resolves the file against the document root. It verifies the resolved file is actually inside the document root, defense against path traversal attacks. If the file is a directory, it calls serve directory listing. If it's a regular file, serve file, otherwise, it returns a 404 error. Serve file determines the MIME type from the file extension, reads all bytes from the file using files.readAllBytes, and sends them with the appropriate headers. For head requests, it sends headers but no body. Serve directory listing generates an HTML page with an unordered list of files and subdirectories. It uses files.newDirectoryStream to iterate through entries, creates links for each, and includes a parent directory link if not already at the root. This gives a clean, navigable directory view. The handle API method routes to 3 endpoints. /API/time returns a JSON object with the current server time and a Unix timestamp. /API/echo returns a JSON object containing the request method, content type, and body, useful for debugging. /API/stats returns server metrics, total requests, errors, memory usage, from runtime.getRuntime, and uptime in seconds. All API responses use the application/JSON MIME type and proper HTTP status codes. SendResponse writes a complete HTTP response, the status line, HTTP/1.1200 OK, content type, content length, connection header, and server identification. It flushes the writer, then writes the binary content to the output stream, skipping the body for head requests. Senderer generates a simple HTML error page with the status code and message, then delegates to SendResponse. These helpers ensure consistent formatting across all responses. The log request method prints each request to the console with a request counter, the HTTP method, and the path. It uses ANSI color codes, green for static files, yellow for API calls. This makes the server output visually clear and easy to monitor. The GET extension utility extracts file extensions for MIME type lookup. A start time field records when the server began, used by the stats API. The main method parses command line arguments for port and document root, with defaults 8080 and /www. It creates a tiny web server instance, starts it, and then blocks on system.in.read, waiting for the user to press enter. When that happens, it calls stop to shut down gracefully. This simple interface makes the server easy to run and terminate. You've built a production-ready HTTP server in a single Java class. It handles static files, generates directory indexes, exposes a REST API, and logs requests with color. This project demonstrates the power of Java's standard library for networking, file I/O, and concurrency. You can extend it with virtual hosts, HTTPS, or template rendering. The core is solid, clean, and entirely yours.